Hello, boys and girls, and welcome to another lesson of Science in Daily Life in the grade 7 classroom. I am Miss Ruman, and I'm here to take you on a fun and exciting journey as we explore more on the solar system. Before we do so, can you recall what we did in our last lesson? Yes, boys and girls, we talked about the different planets found in the solar system. Today, however, we're going to identify the forces that are found or that keeps the object in orbit in our solar system. As you can see in this NASA photo, Earth is tiny in comparison to that of the Sun. Here, Earth is found very small, and you can see the Sun next to it there. The Sun's gravity is relatively strong because the force of gravity between two objects is directly proportional to their masses. Gravity between the Sun and the Earth pulls Earth towards the Sun. But Earth never falls into the Sun. Instead, it constantly revolves around the Sun, making one complete revolution every 365 days, hence giving us a year. Now, think for consideration there, boys and girls. We have gravity, and the Sun's gravity is pulling the Earth, and it's pulling it so strong. But the Earth is not falling into that Sun. Instead, it is going around the Sun because something is there keeping that. And that thing that is there keeping Earth is Earth's gravity. Now, let us talk a little bit, boys and girls, about rotation and revolution. Rotation refers to an object spinning motion on its own axis. Rotation causes day and night for Earth. Revolution, however, refers to the object's orbital motion around another object. As we know, one revolution will give us 1 year. Here you can see the difference between rotation and revolution. Rotation is the Earth spinning on its own axis, and revolution is the Earth revolving around the Sun. So rotation gives us day and night, revolution gives us 1 year. What is meant by the term orbital motion? Earth and many other bodies, including asteroids, comets, and the other planets, move around the Sun in a curved path called orbits. Generally, the orbits are oval in shape. Here you can have a look at Earth's orbit. It is oval in shape. It is not fully circular. Now, because the Sun's relatively strong gravity, and gravity is that universal force of attraction between all matter, Earth and the other bodies constantly fall towards the Sun. But they stay far enough away from the Sun because of their forward velocity to fall around the Sun instead of into it. So they're moving, and velocity is simply speed in a direction. So they're moving in a direction, hence the reason they're not being pulled towards the Sun, or they cannot go into the Sun. The motion of Earth and the other bodies around the Sun is called orbital motion. That way in which it moves around the Sun, it's called orbital motion. Now, orbital motion occurs whenever an object is moving forward at the same time and it's being pulled by gravity towards another object. So think for this. Earth is moving in a path, but yet it's being pulled towards the Sun. The forward velocity of the object combines with acceleration due to gravity towards the other object. This results in a circular or oval path called an orbit. Hence the reason we have an orbit or a circular pathway in which that object keeps moving around the other. Today, students, we identify the force that keeps an object in orbit, and we said that force to be gravity along with orbital motion. Orbital motion is what gives us or gives planet the concept of orbiting around the sun. I hope you join me for another lesson as we explore more on galaxies. Until next time, I am Miss Freeman. Bye-bye.